Hello, everyone. In this video, we're going to look at the second exercise and example coming from 1.3, the derivative at a point of our notes. So in this question, we're told the volume of water in a leaking tank is given by V for volume equals F of T gallons, where T represents the time in minutes. A graph of the function F is given to the right. So here is a graph of the function F of T. So this vertical direction is telling us the volume of water in that leaky tank. So part A says estimate the rate at which water is leaking from the tank at T equals 3 minutes. So to estimate that rate, we can use the tangent line of our curve at that T equals 3. So I'm going to write that out for us. So use the tangent line to F at T equals 3. And how do we use it? We're going to estimate the slope of that tangent line, because the slope of the tangent line is the rate of change of the curve at that point. So let's identify that here. So I want you, if you haven't done this yet, again, I encourage you to pause the video and identify the point T equals 3, the horizontal point T equals 3 on the curve, and see if you can sketch the tangent line at that point. And we'll do it together here. So here we're measuring 6, 12. So each chunk here, a smaller chunk, is measuring 3 units, 3 seconds. So here would be 3. So the point on our curve is up here. And we can estimate that tangent line here. So I'm going to get out my ruler or my straight line feature on my iPad. Oops, let's try that again. All right, so here we have an okay looking tangent line. I had to pause the recording and try a couple times, but persistence. So now let's see if we can estimate the slope of this tangent line. So again, this is our tangent line at the point T equals 3. So to estimate, I'm going to pick 2 points on my tangent line. So I'm going to pick our original point, 3, looks like 10,000. And then I'm going to pick another point here, maybe let's say 18 and 1,000. So then I'm going to estimate the derivative or the slope of my tangent line is approximately the slope of the line I've drawn here. So then I need to compute the slope of the line between these 2 points. So I look at the difference of my y values. So that's going to be difference of 10,000 minus 1,000 divided by difference of my horizontal values, 3 minus 18. So I'm going to compute that quotient. So 10,000 minus 1,000 gives me 9,000. And then 3 minus 18 gives me negative 15. Oops. 3 minus 18 gives me negative 15. And so if when I do that division, I get negative 600. And now we can think about units here. So units of my numerator, volume, is gallons. And units of my horizontal quantity is time. So this negative 600 would be negative 600 gallons per minute. And if we want to write a sentence to summarize, we'd say the tank is leaking. And we know it's leaking because the volume is going down and my rate of change of water in the tank is negative. So we're losing water each minute. So the tank is leaking at a rate of 600 gallons per minute. And it's only leaking at that rate at that time, at T equals 3. So after 3 seconds, the amount of gallons, the rate of gallons that are leaving the tank is 600 gallons per second. Oh, let me rephrase that, per minute. We're looking at minute in the horizontal value. All right, so now looking at part B of this question, it asks us to do the same thing, but now looking at t equals 18 minutes. So I'm going to clear off my graph and redraw my tangent line. If you haven't done this already, please pause the video right now and clear off your graph and estimate a sketch of that tangent line. And then when you're ready, play the video and you can follow along. All right, so here I have a rough sketch of that tangent line on my curve. So I have the point t equals 18, and I've driven an estimate of that tangent line. So now to estimate the slope of the tangent line, I'm going to pick 2 points on that tangent line. So I already have here 18. And it looks like if I go over to the vertical axis, 3,000. And then if I want to pick another point, it looks like I can use, let's see, it kind of goes through this point here. So it's going to be 3 and 9,000. So again, we're going to using that tangent line, use the tangent line at t equals 18 to find the rate of water leaving the tank at t equals 18. So we need to compute the slope of that tangent line. So that's going to be using our notation f prime of 18. It's going to be about the slope between these 2 points. So we'll have the difference of our y's, which is going to be 9,000 minus 3,000 divided by the difference of our t's, which is 3 minus 18. So now 9,000 minus 3,000 gives us 6,000. 3 minus 18 is negative 15. So we compute that quotient, we get about negative 333. So the tank is leaking water at a rate of 333 gallons per minute at t equals 18. So we can say when t equals 18, the tank is leaking water at about 333 gallons per minute.